Welcome to the second season of Optimize All the Things podcast. I'm your host, Bartek Podka.
And I'm your host, Ivan Volkov. Optimize All the Things is a podcast in which we talk about technology, software engineering, careers, soft skills, and really all the things we can optimize in our work and life. And this season, we focus on tech startups.
In today's season, we have our dear friend Frederic Branczyk joining us to tell us more on their startup journey. We dived into Frederic's company PolarSignals beginnings, fun technical discussions around profiling, columnar storages, eBPF, and LLMs. And we touch on some early business principles and tips. I love it, I learned so much, and I hope you'll like it too. Let's jump in. Welcome, Frederic, to our podcast. It's really privileged to have you as our first guest in our Tech Startup Edition podcast season. How are you today?
I'm doing very well. Thanks for having me.
Amazing. We have a busy schedule with some topics to discuss around your story, around tech you build, and maybe a business you run as well. So let's start in. Would you like to maybe introduce yourself? Who are you? What do you do these days?
Yeah, so I'm Frederic. I founded this company called PolarSignals, and I've been kind of in observability and like cloud native space for the last 8-9 years now. So in like 2016, I became a maintainer of the Prometheus project. That's how ultimately Bartek and I got to know each other as well. Ultimately then also became a maintainer of the Thanos project. Again, also where Bartek and I know each other from. Over time, because kind of at the time I was mainly in charge of kind of integrating Prometheus very deeply with Kubernetes. So I ultimately actually also became the tech lead for all things instrumentation within Kubernetes. And so that was kind of the thing that I was doing for a really long time. And then I was doing that at CoreOS. I don't know if people still remember CoreOS, but CoreOS was acquired by Red Hat in 2018. I stuck around a little bit. I was kind of architect for all things observability at Red Hat for a while. That's where I actually also ended up hiring Bartek into one of my teams. I don't know if we want to jump straight into the founding story, but ultimately that's my background.
I think it would be super interesting to hear how you made the jump from individual contributor, architect, working kind of deeply into the technical problems in different companies to founding your own company. So tell us a little bit more about that.
So I think one thing that's worth noting is it's technically not the first company I've ever founded, but it's the first product company I've founded. So I used to own it was just me, but I did like consultancy work when I was in high school and into college a little bit as well. And so I think I've always had kind of a little bit of an entrepreneurial spirit. And so I feel like I always knew that I wanted to try something again, but I also wanted to make sure that I got real exposure and didn't just start to real companies, and don't just start a company because I want to start a company, but because I see opportunity, and also I've seen things that I don't want to do, right? In particular, like that's not tech related at all, right? That's entirely about how to build a company. Ultimately, what led to kind of starting the company was, I think, several kind of frustrations that I had in my role, where both I had a lot of power, but also didn't actually get to build the things that I felt like we needed to be building, right? And long story short, I think that's kind of snowballed into starting the company, because I started this like really scrappy open source project that I very creatively called ConProf, right? And I got incredibly lucky and got to present the whole idea as part of a keynote at KubeCon. And so I felt like there was opportunity there, right? And there was basically no product on the market at the time, but we knew that Google had been doing this for a really long time. And while this was a really terrible piece of software, and I think Bartek probably remembers it.
It was actually amazing. I loved it, and I was using it for years before you kind of like ended up doing product with it. So.
Yeah, right. Like that's kind of the beauty. Like I say terrible piece of software from like an engineering perspective, right? Like it was not well tested, it was not well designed, but it worked. It worked, and it brought so much value to the teams that I was working with at Red Hat, right? And so I think this is ultimately why I saw opportunity, right? Like people wanted to hear about this stuff on the big stages. We saw real value being created within the teams that I was working with, and the landscape was pretty much empty. And so that's ultimately why I was like, okay, there's opportunity here. I was already advising some VCs on their investments, and so I felt like if I really needed money, I feel like I have enough connections to be able to raise money as well. So yeah, I think that's when kind of everything came together, and I was like, it's now or never.
Awesome. And tell us a little bit about PolarSignals, or maybe what did Conprof initially do? What it evolved into, and like what is PolarSignals solving right now?
Yeah, maybe we should start from take a step back. We do continuous profiling. So people maybe are familiar with profiling, but even if not, profiling is kind of as old as software engineering itself is, because with profiling, what we do is we, let's say, look at a single process for a 10-second period of time, and we essentially record what the program is doing so that we can reason about where our resources being spent. So that can be CPU, that can be memory, that can be network IO, it can be all sorts of things. And continuous profiling, it's kind of in the name, as opposed to just going reactively looking at a process. We're just always doing this. And the simplest reason why we would want to do this is kind of the same as any other observability, which is you're always going to want the data that you don't have. Like, let's say you have this kill, right? And you want to know very badly where was all this memory being consumed right before this process got killed, right? That's like one of those really extreme examples we like to use because it creates emotion within people. They've had these situations, right? But it can be simpler than that, right? It can be there was this CPU spike or a latency spike. Why did this happen, right? And finally, we can answer these questions with data and not just say, probably it was garbage collection, right? So no, we can actually look at the data and say, no, this was not garbage collection. This was actually this weird pathological user interaction that we just never know how to trigger, right? But now we have the data and we can actually look at the data.
Yeah, and I know that there is an interesting story behind the name PolarSignals. Can you tell us a little bit more about that? Maybe like all the open source projects, Parka.
Right, so kind of actually tying a little bit back to the previous question that you had. So originally this was called Conprof, right? Like super creative, Conprof, continuous profiling, right? Anyway, so we came out of the Go ecosystem where profilers are amazing, right? Like the profilers that are built deeply into the Go runtime are really, really high quality, super easy to use. Typically you serve them on an HTTP endpoint and you can just curl them and kind of scrape them Prometheus style. And that's how Conprof originally worked, kind of a pull model exactly the same way as Prometheus does. Over time, we realized while collection of this data is a solved problem in the Go ecosystem, it really isn't a solved problem anywhere else in any other ecosystems. Some ecosystems have pretty good profilers as well, but ultimately we realized there's got to be this like holistic profiler that truly profiles everything. And I mentioned earlier that Google had been doing this for a really long time. They actually wrote a paper, I think already in 2010, where they were describing that they're actually profiling absolutely everything in their infrastructure all the time. Now, I don't remember exactly anymore whether they were saying whether it's zero instrumentation, but we felt that was the only way that we were going to be able to make this happen in the real world that isn't Google, right? Like Google can mandate a bunch of things. They can say you have to use this compiler flag, you have to do XYZ, right? You have to use this library and so on. That's not the reality of the outside world, right? So kind of unintentionally or like unplanned, we became an eBPF company as well, where we're using eBPF to build this kind of monolithic profiler that can profile Go, C++, Rust, Python, Ruby, JVM, whatever it may be, right? And yeah, ultimately we kind of flipped it around, and while we still maintain and we can still do the like pull model, our primary mode of operation now is actually through our agent that you deploy on every host in your infrastructure. It automatically starts profiling everything in your infrastructure and then pushes the data to a Parquet compatible server.
Amazing. Yeah. So it sounds like we slowly moved into a kind of technical discussion, which is amazing, which was the plan. But I'm kind of very, very curious, like, when did you realize this kind of zero instrumentation is the way to go? When you started company, because like I was remembering I was working with you, and then you kind of changed jobs to kind of found your own company, which is amazing. And then, did you realize at that time that, okay, like scraping based profiling, continuous profiling wouldn't be enough and you need to do something around zero instrumentation, or you realized that later?
Definitely went about it pretty naively at the start. And I think this is a theme for if you want to start a company, you got to be a bit naive about just about everything.
Exactly.
I don't think a lot. I don't think a lot of people would do it if they were naive and kind of a little bit oblivious to a lot of things. But no, I think at the start, we thought that the big problem was how to store and analyze this data. And to be fair, also really hard problems. I think it was only a couple of we put together this like super minimal proof of concept that we could give to companies to try out. And we had like 4 or 5 companies after 4 or 5 months that were trying our product. Again, this was like not at all like scalable or anything, but we just put something together to give to companies to give us some feedback, right? And I think that was kind of the point in like 2021, January, February, something like that, where we realized, okay, collection is great in the Go ecosystem, but to capture like Python and Java, which are enormous ecosystems, we would need to do something very different. And we kind of went back to the drawing board and we were like, okay, we don't want to just build bespoke integrations here or there that all then end up working totally differently. In Python, most profilers are like wall clock profilers, right? Whereas then in the JVM, you have like safe point bias, and we're like, we need to build something where data is actually comparable, where one profile from one language is actually comparable to the profile of another language. Where like the number of seconds that you see in the profiling data actually, they mean the same thing. So that's ultimately why we're like, we need to build something completely from scratch that just profiles absolutely everything in exactly the same way. And that's ultimately how we got to that.
Can I maybe step in and ask why comparing profiles from different languages is so important? Because it feels like nobody would ever compare like details around what in my Rust program, influences this slowdown, and then in Go and kind of try comparing that same screen.
Yeah, so it's I don't mean that literally in that you're comparing 2 implementations of the same application maybe or something, right? how often would that even happen, right? I'm more talking about one of the key points that Google had laid out in one of these white papers was you need to be able to view all of your CPU time across your entire fleet, right? And if you have different profilers having different meaning to the things that they're measuring, you can't actually put them in one view, right? You can't say, okay, this application is actually using like 25% of all of my resources, and even more importantly, 10% of all my resources across my entire fleet are spent in this function, right? So if I optimize this function away, it's going to translate into a real 10% cost saving on my cloud bill, right? If we don't have comparable data, you could smash everything into one view, but it would be meaningless, right? The data wouldn't actually make any sense.
Makes sense. Yeah, thanks. But just to catch up on this, who compares the same application in different languages? Like, I think all the time we compare. I was just reading benchmark from OpenTelemetry client libraries, and then you have other vendors comparing and doing benchmarks. But this kind of, but you don't need maybe like literally profiles of those. But what you are discussing about aggregating, some kind of summarization numbers based on profiles, like, is hitting. Like, some people might be surprised. It's like, oh, I was looking inside the process. Now we are talking about group of processes, which means there is some kind of metric creation out of profiles. Can you share more about like this kind of feature? Because it sounds like, yeah, it's not normal profile use, maybe.
I mean, I think there is kind of an evolution that's happening where, with continuous profiling, we're not just looking at a single process, right? We're looking at a bunch of different processes across the entire infrastructure. It may be similar processes, and similar processes would then end up getting merged in the reports and stuff like that, right? So I don't know if this is exactly the answer to the question, but like with continuous profiling, all of a sudden we have not just individual points in time of data, right? But we actually get a really holistic view of our entire infrastructure.
So there is like a bunch of things that you kind of have to build in order to make all this successful. You talked a little bit about collection of all the different profiles, a little bit about storage and querying. I know that you had to build your own kind of columnar data storage in FrostDB. Like, why did you have to do that? Like, what is it solving for you guys? And like, couldn't you just use anything off the shelf?
Yeah, so we came from the Prometheus ecosystem, right? And so both our bias, but also our early users were basically validating that people want a Prometheus style experience from a product like this, where they can add any label to the profiling data that they want. They can control this, and they can essentially map their organization onto the tool, not that the tool forces some way of organizing the data onto them, right? And I think this is one of the things that have made Prometheus incredibly successful. And so that was one of the reasons why we were really insistent that this is the type of query experience we've got to have for a system like this. But this actually poses huge challenges, because the reason why Prometheus is able to do this is Prometheus essentially does a like two-step query, right? Like it first queries an inverted index to understand which are the time series that I need to read. But this is kind of problematic because, at least in the way that Prometheus does it, the inverted index is relatively small, and so the search space is pretty limited. People often hear about like cardinality explosions in Prometheus, right? The thing with like stack traces is they are almost by definition unique, right? And so a Prometheus style storage just wouldn't have worked at all. We actually tried at first because we were like, we got to build something And we got to experiment at least a little bit, and maybe we're totally wrong and this would work just fine, right? But it turns out, it very, very quickly fell over. And so we went back to the drawing board and we were like, what are the properties that we need from this storage, right? We need to be able to aggregate very quickly. We need to be able to search really quickly. And ultimately, we want the operation of this stuff to be relatively simple, right? Aggregations, the fastest way to aggregate data is to lay them out in memory in a contiguous fashion, right? Prometheus actually does this as well. And this immediately made us think of columnar databases, because this is literally how columnar databases lay out their data, right? But there's kind of it's kind of paradox almost that you want to combine fast searching and columnar databases. And so what we looked at is how can we map these like labels onto existing columnar databases. So we did look at existing columnar databases at the time. And the best thing that we could find is like map style data types, right? Where you have a column that is a map that then has the key value pairs within them. Now the problem is you still need to do a linear scan over this column now in order to find the values that you're searching for, right? Which ultimately means we've gained exactly nothing. We've basically created like relational database out of this like columnar database, right? And so we were like, what if each label name was always its own column, right? Then we would be able to kind of search individual columns very quickly and be able to aggregate by them really very quickly as well. The problem is this didn't exist. Like a database that kind of on the chunk level has dynamic schemas where we can dynamically expand this label column whenever we see a new label, basically. And it's actually really important that this is on the chunk level because maintaining a global schema is pretty much impossible, because you'll have thousands, tens of thousands, hundreds of thousands of label names, basically, and that just ends up not scaling. So you kind of need to have a semi-flexible schema, but within the thing that is flexible, you can still define like strong types so that you can use all of this to inform optimizations in your query layer. And so this didn't exist, and so we needed to build it. Now, I will say if we started again today, there are probably things that we would be doing differently, but at the time there was just nothing.
Interesting. So sounds like this journey, is partially implemented. I mean, literally you can download Parka tool for yourself. It's open source and like a single node solution just works. And I know because we are using it across ecosystem, including like Prometheus benchmarking system. And so I wonder, in the percentage, like from 0 to 100%, like how would you say your database is, implemented? Is it 50%? Is it like from the things you wanted to do it?
From the things that we wanted to do, I would say maybe around 50% is there of what we want to have in the future. There are a lot of things. I mean, I can always dream, right? And probably, databases that have existed for 25 years, there are people who are still dreaming about, what it'll be in the future. So this may even be, if we fast forward another 10 years, I might still say 50%, right? I don't know. But there are a number of things that we definitely still haven't implemented. And the biggest reason is really just that we haven't needed a lot of features yet. Yeah. But there's a very, very long tail of features that eventually will make it into the database.
And to be specific, I think you have a kind of single node solution of this FrostDB like working good enough, let's say. I feel like you were also working on some cloud scalable, horizontal scalable solution as well. What's your next step? What's the kind of thing that you're working on?
I mean, this entire database is an implementation detail of our product, right? So we never really go about it in the sense of what is the next feature that we need to add to this database. It's always some like requirement that is coming more from what do we need in this continuous profiling product. And actually, in terms of the database, pretty much the entire year of 2024 is going to be about performance and scalability. At the moment, it works and stability. At the moment, it works perfect for our customers. Although I shouldn't say perfect. Like we haven't had any major incidents, for example. We haven't had data loss in a really long time. The thing that is a little bit frustrating sometimes is if you have really, really enormous amounts of data, then queries can get slow, right? Like that's kind of a natural thing even, right? Like the more data you need to process, the more resources at the very least you need to spend to crunch through them. But yeah, it's kind of scalability, performance of queries, and stability. And actually, I gave a meetup talk yesterday about stability because building a database is actually kind of crazy, right? Like all of a sudden you're handling all of this data and your customers are trusting you to like safekeep this data and that it'll be durable and that they can query it and so on, right? And so it's kind of a daunting task to make sure that this stuff actually works. And trust is something that is really hard to gain with customers, but extremely easy to lose. And one very sure way of losing trust is dropping data on the floor, right? And so we were kind of, I said earlier that we haven't had data loss in quite a while. Now that's awesome, right? But it also scared me a little bit because I didn't really understand the failure modes of our database very well, right? It hasn't failed in a while, and that kind of made me nervous. And so we were looking around, and there's been this kind of movement in the database industry for some time. Actually, the oldest implementation of this that at least is known within this name as well is 10 years old, and that's deterministic simulation testing. So the idea here is essentially you're making your database, or really this could be anything, but I think it's particularly widespread in databases because exactly what I just said, you really want to get databases right. And so with deterministic simulation testing is you want to get your database to be deterministic so that you can produce random operations to be run against your database that you can then test whether data consistency holds true, whether some invariants of your data continue to hold true, and that way you're almost fuzzing your database basically to make sure that under extremely random operations it still continues to work the way that you expect. And there's a company called Tiger Beetle that has measured quite precisely how much like simulation time they're basically actually simulating real usage, right? And I don't remember the exact numbers anymore, but I want to say it was something like every day they're simulating 2 centuries worth of production use, right? And this is how we can build robust systems that don't take 20 years to mature, right? We can actually exercise them in ways, in random ways, but these random ways do eventually occur in production, but extremely rarely, right? But we can exercise them in kind of a systematic way. And this is how, long story short, we're actually going to do a blog post today or tomorrow about this, where we're diving deep into how this works. But long story short, this is how we're improving our own confidence in our database.
Yeah, this is amazing. Like I just spoke to to one person a week ago, and he mentioned also like he did like master thesis and like this. They even created like the project LazyFS, which kind of simulates some file system to introduce certain kind of failover situations. So it's kind of it's getting more popular. It's interesting. Maybe question to you, like have you found already some bug with it or not yet?
Yeah. So as with anything, we were also skeptic, right? Whether this is actually going to be fruitful for us, because at the end of the day, you need to make your code base mostly deterministic, and like a big part for us was actually making the Go runtime deterministic, which it intentionally doesn't want to be. So that's something I'll leave for the blog post. But yeah, we were skeptic whether all this work is going to be worth it, right? But it turns out we haven't actually even run the simulator continuously, and even just during development, we found like one crash, like 3 data losses, 2 duplicate writes, and this was just during development, right? So we found it to be 100% worth it. These are data loss bugs that never, like, we've prevented them from ever happening in production, right? And this is really the power of deterministic simulation testing, because we've been able to kind of simulate a bunch of random scenarios that definitely can happen in production, right? But we've prevented them from actually happening in production, and that being the cause of why we're investigating this, right?
Awesome. We have like so many questions around tech that we want to ask, but we'll try to kind of limit ourselves. I'll have a final question about tech before we jump into like some more, I guess, startup / business questions. But you said that you are an eBPF company, right? You leverage eBPF to kind of get a lot of profiles from different programs written in different languages, and that's awesome. But tell us about some of the limitations of eBPF, like some of the things that kind of you want to do but can't do because of eBPF, and like how do you think about tackling these problems?
Yeah, I think the biggest difficulty with eBPF is the verifier. Maybe just a super quick explanation. So eBPF essentially allows you to load programs into the Linux kernel to extend it in a safe way. And the verifier is one of those things that ensures that it is indeed safe. So one thing that it ensures is that your program will definitely halt, which is kind of a weird thing because it essentially solves the halting problem, right? But it solves it by essentially saying you can't write like Turing complete programs, basically. There's an instruction limit up until the Linux kernel 5.3. I think the instruction limit was like 4,096 instructions, like really tiny. After that, it was increased to 1 million instructions, which is still sometimes challenging, but yeah, the verifier is ultimately the hardest thing. But there are various ways to get around this. I think there's kind of a love-hate relationship. I think it's sometimes similar to like the Rust borrow checker, where once you've learned to deal with it, you kind of start to appreciate it as well, because all of a sudden we can say we'll definitely execute at most 80,000 instructions and that's it, right? And so we can like be really precise about the kind of overhead that we're also adding to a program being profiled, right? So yeah, I don't know if it's really that big of a limitation, but it's a gigantic learning curve.
I see.
Anything about those memory profiles? I think it was kind of like hard to implement them as well. What's the future?
Yes.
Will it be possible across languages?
So I think we are inconclusive about this. So anything that's sampled is definitely possible, right? So like allocation profiling is certainly possible. Like network I/O profiling is certainly possible. Things that are more challenging are things like heap, because this is kind of a runtime property, right? Like the runtime basically allocates and perhaps even, is like in the Go case, for example, is the thing that actually also frees it. And just to kind of visualize this for some people, basically the way heap profiling works is that you record which stack has allocated some memory that hasn't been freed yet, right? And so in order to be able to correctly track this, you need to track every single allocation and then also track whether this allocation has been freed yet. And this is a pretty expensive thing to do and track.
You need to kind of re-implement garbage collection, kind of, right? This scanning mechanism, so it's hard.
Yeah. We still think this could be possible, but it may actually not involve eBPF.
Still zero instrumentation, or now it has to be a little bit of instrumentation?
So at the moment, it requires a little bit instrumentation. So we already support this for a number of allocators. So like JE-malloc is something that we support, the Go allocator. So we can already do this for a couple of things where it's really, really important, and our customers really, really want it. But I do think there's a future where this could still be done zero instrumentation. It may not be like if we look at, for example, the Python interpreter, it does allocate and free things for you, right? I don't know whether a generic zero instrumentation mechanism would be really useful, right? Because it's the interpreter essentially doing all of this for you. So yes, you would see which parts of the interpreter ended up allocating this stuff and perhaps hasn't freed it. But yeah, I don't know. I think, like I said, I think we're a little inconclusive about this. I think there is something there, but we're just not 100% sure yet until we actually implement it.
Amazing.
Awesome. All right, let's change topics a little bit. We can see, obviously, you're super technical, but now you have this completely different role. You're like a founder, you're a CEO, you have to think about the business as well. How do you spend your time, other than, your mornings doing podcasts with other folks? Like, how do you spend your time?
I mean, in all reality, like, people don't necessarily like to hear this, but this is marketing,
yep.
Right? Like, this is a really important part of any business. You need to get the word out there, right? And so it's definitely something that I do spend quite a bit of time on. Another thing that I spend ridiculous amounts of time on is hiring, right? Like, and you never really, even if you don't have roles open, or you're not actively looking to fill a role, it's always really important to kind of get to meet people, build connections, and kind of basically already know the next person that you want to hire before you even open that position, right? So definitely a lot. It's maybe a mix of hiring and building connections, but this is a really important part of being a CEO, I think. There's a bunch of really random stuff, right? Like sometimes there's some weird accounting stuff that needs to happen, right? Like as a CEO, especially, we're 10 people. I do just about everything, but I try to spend most of my time on sales. and whatever technical work I do to enable sales or move sales forward.
Awesome. Yeah, it makes a lot of sense. So just to touch a little bit on that, so marketing and sales they're quite connected, right? If you're doing marketing, to me, it looks like you must have some kind of inbound interest, and especially because you're an open source project, a lot of people can try your product first, play around with it, maybe install it even in their production clusters before even reaching out to you and asking for support or like some kind of commercial agreement. How does your sales cycle look like? Is it more this kind of inbound, or do you have to do a lot of outbound as well and trying to connect with the right people in order to pitch them Polar Signals?
So we primarily have inbound sales, and it is exactly like you said that a lot of companies come to us through the open source projects. But there's also something to be said about like investor intros. Investors know other businesses maybe that they've invested in or maybe also didn't invest in really well, right? Like their entire job is studying other businesses, and so they understand which businesses need your product actually surprisingly well. And so a decent amount of our customers have been just like intros from investors as well. But certainly our biggest funnel is inbound through things like this, through GitHub, through our open source projects, through giving talks, and so on.
Amazing. I don't know if a tricky question, but I'm curious. Do you have any, company values or company principles that would, generically help to make decisions faster for you and your employees?
I don't know that it influences how quickly we make decisions, but I think two things we take really seriously are that we create a creative and employee-centric work environment. So one way that we implement this today, this may change over time, right? And I think this is something important to note about company culture. It's important to kind of state your values, but exactly how you implement that is different based on at which stage your company is at. So in terms of like the creativity aspect, something that we do today is we have what we call Meeting Monday, which is all one-on-ones, all sync meetings, everything that is recurring happens on Mondays, so that the rest of the week is 100% focus time, like that you can really dive deep and really, really concentrate, because there's some like really challenging technical problems that we're working on here, right? And I deeply believe that it requires a great deal of concentration to work through some of these things, right? So yeah, I think that's something that's really important. And this one the other one might sound cliche, but I think it's really important, especially in an early stage business, which is we take trust over control very seriously, right? Basically, the default is you can do whatever you want, whatever you think is the right thing, and I trust you that you know what's best for the particular situation, whether it's the code base or whether it's dealing with this customer or whatever, right? Now, very similar to what I talked about with customers. Trust is something that does take time to build and can be easily lost. So like if that trust is abused, then that's not great, right? And then we need to deal with that. But that is our default mode of operation. and I think this is why we've been pretty successful at building really complicated things.
Thank you.
Awesome. So you recently announced another round of funding. So you have raised a little bit more than kind of 10 million already from like some impressive names, GV, Lightspeed, a bunch of super impressive kind of angel investors. But what was interesting to me also in this like announcement post is that you are also mentioning about like a new feature that you're kind of thinking about, the AI-driven performance optimizations. Tell us a little bit more about that. It will be interesting to hear.
Yeah, so this kind of came out of this live stream that we've done. We haven't been particularly disciplined lately in doing it regularly, but over the last year we've done 25 or so episodes of what we call Let's Profile, where we kind of take random open source projects and optimize them, right? Kind of to save the world some CPU cycles, right? That's kind of the idea. And at some point after having done a couple of these episodes, we were like, okay, what if we kind of wrote some pretty good prompts for like GPT-4, taking this code and taking some of the profiling data that we've gathered and kind of, letting the AI do its thing. And pretty early, this was really surprisingly good. And so this is ultimately what inspired us to kind of productize this eventually. And I'll be perfectly honest, there's definitely still a lot to be done here. But the early results from this have already been really successful. Like sometimes the AI has come up with better optimizations that we were able to come up within 2 hours on the live stream. So while there's definitely still a lot to be figured out, and this is definitely why it's alpha, and we're only letting select customers have access to this at the moment. We think there's lots of opportunity there.
Nice. Sounds exciting. I kind of want to try it, but I'll wait for it to go into beta. Can you tell us a little bit, like, what do you think is the biggest factor in making this like the go-to debugging and optimization solution for everyone? Is it improvements in the foundation models that you're using? Is it something else? Is it like adding deterministic steps around the LLM so that you have all of these safeguards? Like, yeah, what are your thoughts on that?
So we don't know if this is going to be the ultimate solution for this, right? But the way we're thinking about it, and this approach has some problems, and I'll talk about that in a bit, but basically the way we're thinking about it right now and how some of this already works is that we essentially in a first step generate a benchmark. The benchmark is then run like you would always do when you do optimizations, right? The AI then optimizes the actual target code, then runs the benchmark against it, and therefore has kind of a feedback cycle whether it's actually working. And this has a couple of benefits, right? Like it tells us whether this code that it generated actually works, right? Is it real valid code? Is it actually faster, right? So this is kind of the model that we're going with right now, and it does seem to be working quite well, but it does have some drawbacks as well. One is this can go on essentially forever, right? And therefore create pretty much infinite cost as well of operating this stuff. And at some point it's not cheaper to do that than having a human do it, right? Ultimately, that's kind of the idea, right? Like make humans more productive, save humans time, right? Save humans money. So yeah.
And there are a bunch of optimizations that are not code related sometimes. Sometimes you just say no to the user. Sometimes you just say no to the feature. Sometimes you can change configurations. So kind of combining those is, definitely some opportunity.
So that's actually the first step where basically it evaluates, does does optimizing this code even make any sense? Like, or like, should you be looking at it at a higher level? This works because we have the combination of all of the source code and all of the profiling data, right? So we have a lot of context, which is also problematic because context windows are growing, but still too small for, having the world as context.
On a different topic, do you think the initial idea for a startup matters? I have a lot of friends that are, thinking about, I want to start a company, but I don't have any good ideas. Do you think that's like a good enough excuse, or do you find that starting to work on something and figuring out what people want is like a good approach? And maybe one example is this AI feature. Like obviously it wouldn't have been possible 2 years ago or 3 years ago when LLMs weren't as powerful, but now maybe it's exactly the right time to build something like that.
So I would say even before I had written a single line of code, this was already part of my pitch. That eventually this was going to be possible. Now I had a lot of faith in the ecosystem to actually make that happen, but it did happen, right? It was certainly a bet. I had no idea if it was actually going to happen, but I don't know. I think I don't want to like deter people from starting companies, right? But like I think my personal philosophy is I need to see the opportunity. Essentially this is the most ridiculous scratching my own itch I've ever done, right? Like I'm like 4 years into it, and so for me, I feel like this is how I need to build companies. I don't think that invalidates people, wanting to start a company and starting a company and then figuring it out. I know people who've been enormously successful at doing that as well. But I don't think it's how I can work.
Yep, yeah, definitely makes sense.
Amazing. Okay, maybe one of the last questions. I would love to kind of learn from you about like how involved you should be in open source while building a company. And to be very specific, for example, recently, Elasticsearch donated like eBPF agent to the OpenTelemetry, and you already have a BPF agent kind of open source out there for a long time. They just, I think, open source it right at that moment. So there's a lot of kind of fluctuations. And generally, what are the pros of being in open source and cons, and is it worth for you to be so involved in open source?
I think that's certainly also a philosophical question. I think for me, if there wasn't an open source component to the business, that wouldn't be me, right? It's maybe more of an emotional answer than a logical one. But there are definitely uses to having open your code being open. One is, if there's this like super weird customer thing that like doesn't really take a lot of work to do, customers might go ahead and immediately just do it themselves, right? Like that's certainly happened. And for us, we were also, I think you do need to be intentional about open source. So for us, we quite intentionally made the decision that like Parka, the open source server, is kind of the parallel to Prometheus, where it will scale as far as the biggest box that you can put it on, but not further. And so really huge organizations do need a distributed version of this, and that's essentially where PolarSignals comes in. So it kind of does something nice where it also kind of segments smaller customers kind of automatically out, and kind of forces the really big ones into a certain direction. And then having the agent open source, I think that's part of building trust, right? A lot of what like sales is just relationship building, right? And asking your potential customers to drop something that has insanely high privileges onto every single node in their infrastructure is a pretty big ask, right? And so I think it's also been useful in that way as a tool to say, hey, it's all open source, it's like byte by byte reproducible, like you can verify that the thing that you're running in production is actually the thing that's produced from this repository. So yeah, I think I have a very specific answer for us, but the more general answer is you need to be really intentional about open source.
Awesome. Thanks, Frederic, for this like super insightful conversation. I have one final question for you, and this is where can people follow you? Where can they find more about PolarSignals? And like, what is the best way that they can try it out now in their projects?
Yeah, so we're on all the platforms. We're on LinkedIn, we're on Twitter or X, and I'm personally also on like Mastodon. And of course on all on LinkedIn and X as well. Trying out the product is super easy. You can just head to PolarSignals.com. There's a free 14-day trial. Because it's this one agent that you need to install, you just throw a single manifest against your Kubernetes cluster and you're done. You're profiling your entire Kubernetes cluster automatically, right? Like that's kind of part of the beauty.
Also, we're gonna add links to the show notes for all the social medias, all the things that we talked about will be linked there. But yeah, thanks again, Frederic. Super interesting conversation.
Thank you so much.
Thanks for having me.
Thanks everybody for listening. We really appreciate the feedback you give us. Feel free to follow us on social media, YouTube, and your favorite podcasting platform. But if you liked this episode or you have an improvement suggestion or an idea, maybe you want to hear about certain topics or have a certain guest on board, let us know. Feel free to use the Google form on this podcast description or reach us directly through social media.
Thanks.
Thank you.